In this video, we're going to look at how to express multiple numbers at the same time with an emphasis on a system called interval notation. Sometimes you may find yourself in a situation where you have several different answers, but it's just a small list of them and you're not trying to include all of the fractions and decimals in between the numbers, for example. To do that, we use these curly brackets, which are also sometimes called braces, and then we just list all of the numbers inside of those, separated out with commas. So this is great when you just have 3 or 4 numbers that are all possible answers, for example. To see an example, let's look at the list of even integers, and it's the fact that I'm saying integers that's excluding us from worrying about all the decimals and fractions between the numbers. So all of the even integers between 5 and 13, well, we have our curly brackets on the outsides, and then the even numbers between 5 and 13, we have 6, 8, 10, and 12. So this way we have listed that there are 4 answers to this example that was listed. What happens more frequently, both in life and in math, is that we do often care about a pair of numbers and all of the fractions and decimals in between them. So when we're in a situation like this, we use something called interval notation to include both the numbers or endpoints and all of the infinite number of numbers in between them as well. So the setup for this is that the smallest number should always go first, and the biggest number will go second. And then one of the important distinctions to make is, are we including the endpoints, the smallest and the biggest numbers of our set? If you are not including one or both of the endpoints, then on those endpoints you use the regular parentheses. If you are including one or both of the endpoints, then on any of the endpoints you are including, you use this square bracket. As a comment, when we are dealing with the infinity symbols, the infinite symbols should always use parentheses, because what we're trying to communicate there is that you never actually hit that number. The idea is that it's a number that's so big we can never hit it. So just by definition, always use parentheses whenever you're dealing with infinities. So here are a few examples we have showing probably the most common form that you guys have used in the past, which is the inequality symbols. We have all of the numbers bigger than 3. So there is no biggest number. That's why the biggest number in this case is infinity. The smallest number we're including here is a 3. And since this did not have a line underneath the inequality symbol, we're not including 3. So this is telling me that I can pick numbers really close to 3, like 3.000001. I can get as close as I want, but we will not include 3 itself. That would have been a bracket to do that. And by definition, we never include infinity either. Now underneath, I've also shown a more graphical representation of this. Many questions or textbooks will sometimes give you the number line as another way of communicating this information. It's not going to be our preferred method of expressing domains and ranges, but it is important to recognize. So same rules for this. If you have parentheses, that means we're not including the number. And then they kind of just shade or darken in an arrow to indicate which direction from that number we're including as possible answers. So this one is also showing me all the numbers bigger than 3 with no maximum number, stopping at 3 but not including it. To add on to that as well, some books also prefer to use open and closed circles to indicate whether you include or do not include the endpoint for the graphical representation. In that case, the open circle is the one that means you're not including the endpoint, but you do everything else the exact same way. You would draw an arrow along the number line and have it pointing to say this is the numbers greater than 3, but not including it. If I was trying to include 3, I would just fill that in, darken it. Next example, now we have all of the numbers that are less than or equal to -1. So this bar underneath the inequality is what's telling me that I need to include the -1 number, but do note that when I'm writing my interval notation, I'm still only putting the bracket on one side. I'm including one endpoint, but because my other endpoint is still an infinite number, I always still have to defer to that rule that I need to use parentheses on the infinities. Since this is the numbers less than -1, there is no smallest number. That's why negative infinity is what I have on the left endpoint. And then the biggest number I'm ever hitting is -1, so that's my right endpoint. And then, like I said, put a bracket on that one only to indicate that we're including it. For the number line representation, you can do the same thing. My biggest number was -1, so I have the stuff to the left of -1 and a bracket, or I could instead do a filled in darkened circle, but still pointing to the left to say that I have the numbers less than -1 instead. sometimes you actually end up with two different inequality symbols, and they may or may not match. For example, this one does include the endpoint, and this one does not. So this is saying all of the x values that are bigger than or equal to 2, but less than 5. Well, there are lots of numbers that are between 2 and 5, and again, I don't want to waste my time trying to write them all out. So my left endpoint is 2, my right endpoint is 5, and then I go back to confirm whether I should be including the endpoints or not. 2 is included, so brackets. 5 is not included, so parentheses. And then I have my number line representation here, which again, I could mark with a closed circle and an open circle on this side. And then by drawing in the dark line or shading in the line in between, that's how I know that I'm talking about the numbers in between. Because they could very easily rewrite this inequality so that I want the numbers less than 2 and bigger than 5. And that, in that case, you would have your arrows on the outsides instead. For most of this class, you can really just focus on this middle row of solutions that I've indicated here, though. This is the one I'm emphasizing, the interval notation. That's how you'll enter your answers on most of the tests and assignments we do in here, because it's usually just the easiest and quickest way to express our lists of numbers. For some quick practice on using interval notation and listing sets of numbers or multiple numbers, let's start off here with number 1. We have all of the prime integers between 10 and 20. Well, since we're not talking about fractions and decimals here, this is actually going to be one of the cases where I use those braces, the curly brackets. And my smallest prime integer between 10 and 20, that's going to be 11. The next number is 13. And then we have 17 and 19. It's very important that you use the curly brackets because otherwise it might look like the interval notation and I'm saying all of the numbers between 11 and 13, for example. But since I have 4 numbers here, that kind of makes it obvious that it has to be me just listing those 4 numbers out. Next, we're going to use interval notation to describe all of the real numbers. So again, real numbers means I do care about fractions and decimals in this case, and we want the ones greater than or equal to 7. Well, that means my smallest number is 7. And there is no biggest number in the real number system, so my biggest number is infinity. So I always like to list my endpoints first, and then I can go back and say, well, this one says greater than or equal to. So since I'm including 7 as an answer, I'm going to put a bracket on there. That's how interval notation marks the inclusion. And by definition, I told you parentheses do not include the endpoint. So this one will be a parentheses. It is absolutely okay to have a mixture like this in your interval notation answers. You're not always including or excluding both endpoints. And finally, here's a quick word problem, something that you might see in life. If children under 3 can get into Disney for free, then we're going to use interval notation to describe all the ages that must pay for a ticket. Well, children under 3 get in free. So something is happening when the kid is aged 3. And since there is no highest age you ever hit, I know it seems weird because it's unlikely to hit ages like 100 or especially numbers like 200, 300, 400, but there is technically no highest age possible. So our smallest number is 3, our biggest number, we're going to use infinity here. We told you that you should always use parentheses on the infinities. And then sometimes you have to think about whether you're including that endpoint or not. The wording here says children under 3 can get into Disney for free. So what happens if it's the kid's 3rd birthday? If he shows up and he is 3, I would hope they would let him in for free, but they will probably not. If the rule says under 3 gets in free, then that means 3 and higher has to pay for the ticket. So this would be the interval notation to express the paying customers at Disney. And that's it for the notes. Thank you, guys.